As I told you before, my name is Diego Cuellar. It doesn't really matter if you are going to call me Herman Alonso. By default, this information is there. Okay, so today's demo, we are going to cover two programs. One is the reinforced concrete cantilever wall, and the other one is the embedded retaining wall. If you, are you going to see that both programs are really similar? The difference between them is really small. So we're going to cover almost most of the topic. Okay, so every time you use the program, by default, the program opens your last job. So right now we don't have any job here, so we have to go to File and start for the new file. File Manager. Well, the commands on top are pretty common. The open one, the new one, new program, import any job. The most important ones are the compress and decompress commands. I will let you know how to use it and how to send also your job for to the technical support to review your job and help you out in so many steps of the learning process. At the end, you will have a small give box which you can click on it, and you will have all the examples available for you learning. So the first one, the example one. So I'm going to help me with the software with this job, just to inform you on the steps of doing the process and doing the process. So before going on, we must set up a few things here in general configuration, just in the globe. Just open it. We are going to set up three things: the undo and review, also the units. After that, the code. We're going to do the undo and review. For default, the maximum number of actions are 5, but we must go up to 20. Okay, don't forget to do that because we don't want to lose information. Then the units, as you can see, we have the MTX system, the international system, and since we're going to work in the English version, so we're going to use the US unit. So finally, the code. Okay, so if I display this command, you can see a lot of normatives that we are using around the world. So for the America, they use the 80 code. Part of the Africa too, except South Africa, and part of the Asian countries, they are using the British standard. Mainly the countries like Malaysia and Singapore, they are migrate to the British standard, from the British standard to Eurocodes. That's why for us it's not really important to do the British standard right now, because at the end they must go into the Eurocode. Since we have a lot of people from America, so we're going to use the 80 code. Yeah, accepted. Then on top we are going to have all the commands, file commands, which is like any other software. For a new job, a file manager, to use it, save it. Save it, you have to do it yourself. The program is not doing it by own. You must do it yourself. A job description is that's the description that we did it before. And also in files, you can have the print, job report, and job drawings. Could be at the end. From here, you can get the job report and job drawing, but on the right side, you have also the icon, the printer, which is called the job report. You can get from there the job report and the drawings. We are going to follow the step by step all the commands from file, job, soil, water, prices, analysis, and health. In health, I remember you that you have the manuals. You can download all the manuals, the usual manuals, the sleep cycle calculation, and also the lateral pressure calculation. In these manuals, you can find a lot of information regarding to the methodology, and also the formula, other kind of criteria that we use in this program. Okay, so in the bottom, to your left, to the right, you have the data entry, reinforcement. Reinforcement means that when you finish with all the geometry and all kind of stuff, regarding to the calculations, we must go to the reinforcement. Perhaps we can change it and complete our job. Our design. Well, in job, we continue with job command. So we go to the show. That means that we must activate the dimension, horizontal, vertical, and the layer information. Okay, so you can do it. You can set up this information right now, or if you want it later on, you want to change something, you can create. You can go back with the default setting. Anytime you see this quotation mark, if you click on it, it could be a frame, a blue frame that you can click on it and get more information from that subject. So accept it. Then in job, we're going to have the type. I'm going to show you the fixed one. Fixed one is like a beam on the bottom. Then the type, the street footing, which is the one we're going to use right now. And then the last one, the type of cutting beam. Okay, so three of them could be possible in this program. I'm going to follow just the street footing, right? Okay, so the materials. But we have the concrete. Because we have the AC code, so we must choose one of those. This is important to notice because the stirrup in this program, we are not creating that stirrup, especially in the wall. So we take in consideration the quality of the concrete and the steel grade. If we want to change something, if you have some problems in the shear the shear factor, so we must go here and change it a little bit. Also, these values are by default, but we can change it if you want. The core in the wall backfill phase, the core in the wall in the infill phase, the foundation top cover, and the foundation bottom cover, foundation lateral cover. In some cases, after the calculations, we must change the foundation bottom cover and the foundation lateral cover. We will see. And the maximum size of aggregate is this value, but depends, the material that you are going to have around the construction. So accept that. Then we follow the general data. So the wall height is going to be 11 feet, and also the height of the wall about the ground level 0. So we're right here. The ground elevation is right there. And could be also backfills, infills, or without level. So we're going to continue with the infill. The wall length of the plan is the height, and the wheel expansion joints could be this one. It's almost the half of this size. Okay. So accept it. We continue now with the loads. In this particular program, because we are following the Bishop method, this method allows you to introduce external forces like seismic acceleration, could be 1% of the gravity, and also this method can help you, to find out another part of the solution that we are going to see later. The infill we can create the infill lateral pressure almost the left side, which could be passive all the time, and the right side could be the backfill, lateral pressure. We are going to use the active pressure. Okay, I'm not going to use the seismic uh, factor. So that's for loads and options. The fabrication loss percentage is almost 10%. Usually that's the key factor. We consider user dimension too. About the safety factor, with seismic factor, we have almost here this information by default too, regarding to the sliding, so overturning, and the worst case failure plane. And in the right side, we can see blue line, blue arrow. If you click on it, you are going to import some values because, as you know, this is the Spanish software. So we got just an idea of the values that we're going to use, but it's only a guide. You can change it anytime. I know that some countries we are limited up to 2 in this case, an overturning factor, but we can go in other normative up to 3. It depends. Right now we cannot go farther than 2. About the walls, we are going to configure the same thing. I'm not going to change anything. The foundation too. The infill perhaps. In the foundation element, it's better to work, well, depends on the case. In this particular example, we're going to use the equal overhand. And the footing, I'm not going to change much. Okay, so continue. Job reinforcement table. Well, in this case, we have by default our tables. I'm going to show you about the vertical backfill phase. I want to show you. Oh my goodness. 1 second. Something wrong. Let me check. Sorry about that. So we go back to the same. So we're going to bring the same project. Okay. So we were in the reinforcement table. Let me check the normative. 1 second. But we were working with Eurocode right now. I'm going to change it to AC. Right. So the reinforcement table, you can change part of the reinforcement table depending of the necessity. If over there in the place there are bars or rebars that are not available in the market right now, but that you can remove it and make your own tables. The program accepts that information, and then every time you are going to do a new job, they keep this information by default. So it's no problem to continue in that way because the program are going to work faster. So I'm going to show you before about the soil. We're going to tell you about the general data. So it gives you now information about the ground level elevation, which is 0. If we have a rock depth, we can introduce it. Perhaps if the rock depth is very close to the foundation element, but we don't need to use this kind of calculation. And also, if we have at the ground level, we can introduce it without any problem. Also, we can create in the backfill or in the infill soil a kind of embankment, and also introduce the angle to this environment. Could be the right side or the left side. Drainage laws, we have to guarantee 100%. Some people say that it's impossible to do it, but at least if we use a software, we can create the environment and create all the situations as much as we can. The percentage of passive pressure is 6%, and depth of passive pressure mobilization 0. So allowed bearing pressure 28, and soil foundation friction coefficient 0.6. Okay. Then we continue with soil. I'm going to edit layers. This layer, the first one on top, if you click here, you will see a lot of description. We do that because we have the soil analysis. So with soil analysis, I give you the apparent unit weight, the submerged unit weight, and the internal friction angle. Also the equation. By default, also we have this table, similar to the last one that I will already show you, that gives you the same information, but just to have an idea what kind of soil we have. In particular, this one, the L1, is around the soil clay, in between soil clay and semi-bar clay. Okay, we are here. And at the bottom is the description layer L2. I'll show you more or less what kind of soil we have. So here also we are in between semi-hard clay and hard clay. Okay, set up. And the other one over here, the blue one, the pink one, is called well, we can call it L3. If you want to call it L3. L3. And the information gives you between hard clay and silt. All right. The finish for the soil. You can create, depending of the soil analysis, you recreate the environment. You can have as much as you want the layer, also the soils, coefficients, factors that we give you from the soil analysis. Now the wall. So the wall, the height of this wall is this 9 feet. The top thickness is 1 feet, and the bottom thickness 1 feet. Also, in so many windows, you will have this kind of open book that if you click inside, you regard more information to that subject. Accept that. We continue with the wall, and I'm going to edit. Well, here we have 2 or 3 parts. The one on top, this is the height. The one on the bottom, on the side, we have a partition over there. And in the bottom, in the foundation elements, I'm going to set up everything overhand on both sides. Okay, the jet, the overhand, and the mud flap. We have another thing which is called GRT, but in Spain and mostly in Latin America, we call it heel. We have to follow this broken line over here in the center of the element in the wall, which is it's not the same in every job. In our job is different. It's a blue line here, just the corner of in the beginning of the corner of this wall. So if we have reference, that reference, if you want to take this reference, we can accept that and we create our heel. That's all for the walls. For the face, so we can create, depending on the construction phases, all the process that we already have in mind. So we can do it, but this is the big difference with the other programs. With the retaining walls, we can do it step by step, more precisely. About the infill soil, we can do something. Also the loads. As I told you, with the Bishop method, we can introduce external forces, and this is one of those. This is the one on top. It's going to do vertical, or in the axis vertical axis, 155 68 pounds by foot. But I'm not going to do anything in the other side. We can create the dead load and light load. And we can edit the loads that already have over here in the surface and the value. It could be at the depth or the given elevation. Okay, in order to keep it in the surface. And the other side, so in the infill, could be the same situation. Okay. But now the analysis. So the analysis, the three factors over here, these three icons, is better to consult it in consulting at the end. So the best thing to do is to do the check first. With this modification, we're going to do the checklist. Okay, 1 second. Okay. Okay. So I want to check it again. Okay, the result shows that some of the checks have not been verified. I'm going to see the project. So we have in details about the general data, the geometry, the description of reinforcement, and code checks. Every time we see something like this, the red ones, that means that we have to verify. So in this case, the minimum horizontal geometry ratio per phase is not verified. The minimum mechanical ratio tension phase vertical is not verified, and so on. We have a lot of things to work here, but also the footing bending, the infill bottom reinforcement is not verified, and the anchorage length for the bottom reinforcement, the top reinforcement, and the backfilling infill and the infill could be changed. The minimum diameter for the bottom transverse reinforcement, the top transverse reinforcement, and the TRQ longitudinal reinforcement, we have to verify too. Okay, so we have a lot of work to do. So we go for the analysis. One thing that I can do for sure is to change this aspect of the hill. I would like to remove the hill. No, I'm sorry. I'm going to remove the hill. I'm not going to use it. And also I can use something that is called design geometry. This helps you, take in consideration just the geometry, the value of the soils, and they give you an idea about the dimension. Okay, now if you remember, I chose the same configuration in the foundation element to the right side, to the left side. So that's why giving you the same values to fit and to fit. Okay, so then I'm going to check with this geometry if we are okay or not, if we are going to fix part of the problem. Some of the checks have not been verified. It doesn't really matter. I'm going to go right away. Okay, so now there is another opportunity to design everything, to design all. So I do design all. Okay, and we go all the way through, and you will see that many of the topics are fixed, except this one. The anchorage lines, infill top reinforcement, the minimum and calculated is not verified. Okay, so it's not too much, but we must change it. That's been anchorage line. Okay, so we're almost done. So that change, we'll do it in the reinforcement. So I go for the reinforcement. Okay, so every time you pass the cursor through all these bars or reinforcement, you're allowed to change it. So you click it, you will have the opportunity to change out of the bar, to verify the situation and change it. In this case, we go on the bottom, and I will see that the extended square plane is 2 feet inch. So I'm going up to, for example, okay. And also we have to go back to the data entry options. Remember that the foundation, we're going to change it to 3 and 3. Okay. So we go for the analysis again, one more time. Okay. So we have the same problem in field of reinforcement. Maybe see, I'm going to set this one too. Okay. I'm going to change it to overall the pad footing. Okay. And check. So as you see, they're getting better. The encouraged length we must change according to the code AC code 280 Article 12.5.1. So the backstop field could be minimum 1 feet, and we are calculating 3 feet. So once you finish with this, it's only just done, almost done. But we can see also the 3D view. It's pretty cool. They give you all the in detail, even the dimensions, rebar, the thickness, everything. If you want to keep this view for your records, you can here print, perhaps in AutoCAD DX file or DWG file. Just give it the way the place that you are going to keep this information, perhaps in your desk or whatever. You see, and then also you have another key. You can use the background color, change it. You can take off reinforcement or the funky one, and also you can introduce the background, the ground, and also the materials. The materials to see it better. If it is the case, don't worry. Also, the icons over here that we're even the AutoCAD tool, the icons we can display by the reinforcement. We can go here by checking designs, 3D view, and to edit or delete our information. I think I'm going to do the job report. So we missed something, but doesn't really matter. This is all the index, the code, the loads. We are going to see it. This is the thing for all the programs. but the side programs are the same. So even this icon, you can introduce your icon depending on the company, the report selections, the code and materials, the loads, general data, so description, the layers. As you can see, it's pretty neat, easy to understand. You can also export this document to text format, HTML format, PDF, or whatever. Even if you want, if you have some tables, perhaps this table is written in Word, but you can send it to Excel format and continue with your own calculation. So that's a report. If there's something wrong, it will let you. It will let you know what is the problem. We must go fix it. If it's not fixed, still this color on top. So give you already tick off. We have a resume about at the end, the total. Okay. And also the 10% of less. All right. So if you want to go for the job drawing, so we must create one. Well, we have to add new element. In this table, we can increase details. Details means we have a library here. Perhaps one of those examples could be help you in your presentation. So check it out and find which one could be suitable for you. Okay, I'm going to do that. I'm going to choose that one and also accept. So you accept. And title block, you have a lot of things, perhaps not including one, the side one, the telecommunication one, and the empty one. I'm going to use the side one and accept that. Also the peripheral, you can do it by DX file or DW files or PDF. So accept that. This is an extra information regarding the architecture, the location, the owner, whatever. So we go here for vale. So we see we have two drawings. One table which is really important to show you is that one, is the resume for the wall, the position, the number of pieces, the length, even the shape or the rebars, and the bottom, the total one. Also, you can introduce an extra document, a new drawing. Could be the A3 file. You can change part of the information to move, for example, this subject here and do it again. Okay. Well, I'm going back to the cantilever wall because I wanted to show you how the program works with the Bishop methodology. It's simplified Bishop method. This kind of method, I have something here. I'm gonna bring it for you. I have it already here. 1 second. Just me 1 second. This document, even it's written in Spanish. I'm sorry about that. I couldn't find it another way, but I want to show you just quickly the method. Okay, that's the method, Bishop method. And with this method, we have several things to take into consideration. We have already, we have some curve. We start with one of the curve, the circle, And with that circle, we create a center and ratio of that circle. But at the end, we find out that if the factor, which is security factor, which is the most important thing to do it. So we once we finish with the first factor, we go for another curve and we find another center, another ratio, and so on until we get the minimum factor. And this net that are in top will give you an idea of how many calculations we can do it. We have a lot of facility with these computer tools, but it's easy to recreate all the foundation elements and to follow the visual method. I know that we have a lot of information regarding to soil retention walls, but this method is so popular, is very comprehensive, and also we cannot say we cannot believe in 100% of all the methods because all of them have failures. But this method at least can give you the opportunity to create or to introduce external forces, and also all the layers that we have, because they are introducing kind of layers. They over here, 1 second. These are all the forces that we introduce in one layer. So after that, we do the final result, which is the impact. That's all the lines or circles that we are calculating. At the end, we have the same point, the center, and the minimum one is the one requirement. The forces between the layers, we are not considering that because we suppose the soil is stable. It's really stable. I'm sorry, I have information on this one. Okay, sorry. And also create, over here, we can create not only circle shape, we have different shapes in this methodology. Okay, I think that's all for the method. What else? Okay. I forgot to tell you the result. Sorry about that. So here we have the configuration. I prefer to see all this information with X values and Y values. So the blue line is the cell weight and cell pressure with surcharge. And the cell weight and soil pressure is the green one. So you want to see the axial and the shear and the bending moment, the air pressure, and the hydraulic pressure. We don't have it, so that's okay. Now the analysis, we can see the same values, but and in different shape, in different way, as a diagram. We can create here the shear, the bending moment, the air pressure, and the hydraulic pressure, hydrostatic pressure. Well, and the worst case failure plane, a worst case scenario. We can create the maximum and the minimum. And we are looking for the safety factor that I'm telling you before. Here is 1.62, which is the minimum, which here, over here, the minimum. We have some consideration that we don't have to take care. For example, if you go to the manual, the using manual, you go down. By the way, it can take quite a long time to learn this program. It's quite easy. Okay. Wait, I'm sorry, I opened the wrong one. The sleep cycle calculation. Here, they explain a little bit about the program. So this is the fourth consideration that we are not taking care. This one, for example, the circle goes into the rock, the level is just closed, so we don't take that consideration. Perhaps the circle is on the left side and doesn't touch even the retaining walls. And also the circle are taking part of the information from the infill or the backfill. And also the last one, which is this one, the circle is inside, but it's very low compared with the other color curve. Okay, so I think, well, that's the slices that I'm telling you. Okay, so that's it. This is it for this program. I'm going to show you now another program which is almost the same. Okay, so we go for the embedded retaining wall. Okay. As you can see, well, I haven't written in all the information from the chat, but I'll try to do it one by one. About the bending moment and shear forces diagram across the wall. Do we get access to those? And all the person say, and is there an option for the use to anchor ties and reinforce air? I am viewing all my all right. All right, so I will explain you later, okay? So we continue with piles because it's almost the same. Don't forget to do the examples. I'm going to do the retaining wall. Okay, here the differences between the other one is the faces. Or here you can create all of them one by one. Okay, I'm going to go for the first one, the cantilever, the phase one. The second one, the axis anchor, and the extended with anchor, foundation, floor slab one, floor slab two, three, and remove anchor service and service. So depending on the constructions or your experience, you must do this. In this case, I'm going to the first one, to the cantilever. So if I go one by one, this is the first one, anchor one, and then to remove the soil, then to create the slab, another slab, another slab, and the final slab, and the service, the loads that you want to give in service. Here, if you go to the beginning and run the analysis, especially for the worst case failure plane, it gives you details if we are okay or not, if the safety factor is in the right track. Okay, so we continue here. At least the safety factor is verified. If we go for the next step, we can check one step by step. All right. Next one. All right. So I think this is the previous the foundation. Once we get the foundation, there is no need, to continue with this analysis. So all right. So I want to show you that I'm going for the next for the foundation, and they say it is not necessary to check the global stability. Okay. So something external in this software is the support element. You can see this. You can edit one. This well, in this case, you must have all this information previously. because we don't really check so much. We have to take care about the angle, not to cross, not to cross more than 25 degrees in this case. So all the data that we have here is because we know it previously, but the program doesn't really matter, doesn't realize much information regarding the anchor. So it's better to have it before, to do it before on your own, and place it here. We only check the if it's active or passive anchor. Okay. These values, for example, in pounds, is because we already know previously. And another thing that we have in this particular program is that well, the phases I already told you. Don't forget to introduce the body table. And the process, construction process, depends on your scale, no? On your scale. And the final result is almost the same, okay? The same like the other one. So that's all. I think you can get the same report. Well, we have different types here. I forgot to tell you. This is the generic and the retaining wall. Now we are using the reinforced concrete slurry wall, and then we have the reinforced concrete second piles walls. This is micro pile screen, and also the steel shield piles. We have some people who pay for being here, no, in company. So we have that metal sheet pile or generic profile. That's the types of walls that we can share. So the methodology, construction methodology, you will have it on the net, on the web. Free. I can cover. I will show you the important. Okay, I'm gonna show you that part. The length, is written here. We have different process and methods to work with. Well, sorry. 1 second. Give me 1 second, please. Okay. Okay, so in general terms, this is it. Well, I'm gonna try to go through the questions. Well, in the list, you will have the bending moment calculation and the shear forces diagram. You will see it already. Of course, you have all this information for you. It's available, and you can see it. Well, Marius, regarding to the anchor or ties, it is this information you must have it before, and we don't do anything about the anchor. We don't even take care about the resistance of the material, the steel. Still, we don't really care about the support element in the anchor. We only take care about the tension, the force, the strength of the element at the end, if it's active or passive. And that's what you have. No, no, there's not really too much information in that part. I'm sorry. All right. Okay, any more questions? Even for Andrea, Greg, Margaret Papagani. Mhm. The guy with the number 8480118914. Do you have any questions, Mr. Number? Well, I think this is it. Thank you for all of you to be here. I really appreciate that. As you can see, the program is pretty neat, quite very intuitive. You can work on learning so quickly. Okay, thank you guys. See you next time, next demo. We're going to have another one on Wednesday. Could be on Boss Culver. I will suggest you to be here, to be there. Could be something very interesting too. Thank you so much. Bye bye. Andreas, when you say, what did you mean? Oh yes, of course, of course. I'm recording that, no problem. For sure, I think the best way to get it is to be in contact with this guy, Frank. Frank is in charge of the English-speaking countries. So the best way to get it is through him. Okay. All right, Andreas. So thanks a lot. Bye bye.